So we have SOHCAHTOA. From that understanding, I know that sine theta equals to opposite over hypotenuse, right? But if I'm looking at it from the perspective of this triangle here, we always look at the angle we've been provided, or the one we actually want to have as our, we call it the reference angle. So let's say that this is theta, and the theta is that Greek letter that looks like an O with a weird eyebrow. So we have that theta there. Opposite hypotenuse makes sense, right? But what happens if we have a unit circle where the radius of that unit circle is 1? Right? So last time we talked about the unit circles called the unit circle because it's got a radius of a single unit. So if I draw a line that looks like this, and I'm trying to replicate the line that's the same as the triangle above, we can see that, well, we have a radius of 1. And whatever value this point there, because remember, it's always about that specific point. Whatever value that point is there, it's going to be y. Let's just call it y. Okay. Remember, it's opposite over hypotenuse. So we know what opposite and hypotenuse are. I know that my opposite is y, and my hypotenuse is 1, which means that we just get y. Okay. We talked about this last lesson, how depending on how high or how low that value is what sine tells us. Now, same vein, if I'm looking at a cosine, we're looking at cosine of theta equals to, I should fix that up, of theta equals to adjacent over hypotenuse. Same idea. The adjacent is this one over there. So I'm looking at that being the x value, right? So that's the x value of my point. And once again, it's divided by 1 to give me x, which is why we know that with any of these triangles, cosine is x and sine is y. Do I have any questions about that? No? Okay. So with this in mind, if I was to draw a unit circle, let's get rid of this stuff over here. If I was to draw a unit circle and I'm looking at it being symmetrical, right? Let's say I have this angle over there, which is 30 degrees, and that point is right there. Okay? If I go and look at it from the other perspective, we always start from this side, by the way. We always go from here and we go around that's not clockwise, anti-clockwise, right? Because going this way would imply negative. So we always go this way around. If I go all the way around, up until this point, and remember we're looking at a symmetrical property. So imagine if it's like a mirror and mirrors that going that way. Would you agree that the x value is the same, except one's negative, one's positive? Yeah. And would you agree that the y values are both the same? And in this case, they're both positive. Yeah. So with that in mind, what angle would this have to be?
30.
30, good. And in turn, what's the angle that gets me from this point A all the way up to this point there?
150.
150, good. So intuitively, we know that sine 30 degrees, which is what we just got here. And remember, we're looking at the y value, right? So the y value, or how high that point is, let's call this point 1, is going to be the same value as point 2. So sine 30 equals to sine 150 degrees. Do I have any questions about that? No? Okay, so, and I can actually continue this, right? If I was going to continue, and once again, symmetrical property, if I do one of these and I'm looking at it from this angle there, let's get rid of this over here. Same thing. I'm going to say, well, let's go and draw this line there. What degree is that? 30, thank you very much. And is the y value the same? No, it's the negative version, right? And that we know that, remember, from the asterisk thing that I was talking about. And I say that weirdly, you guys will never forget that for the rest of your life. So, as we continue, I know that it's just the negative version of the same value. So, sine 30 degrees equals to negative of sine. Now, how many degrees is it from there to there? 210, good. Of sine 210. Okay. So the negative version of that gives me the same values. And intuitively, it makes sense that if I do the same thing on this side, that's 30 degrees. How many degrees is it from point A all the way up to here? Oh, sorry, I forgot this. 360, good. But then I'm going from here to there, which is how many degrees? 3 what? So the whole circle is 360 and I'm taking away 30, which gives me 330 degrees, right? So I know that this point here, so sine 330 should give me the same value as sine, and we said 210 degrees, because they're both at the same y value, though given that's negative. And the same idea applies to cosine as well, right? Obviously with the different way of looking at the asterisk thing, but the cosine is the same idea as well, where we have that symmetry, and we go, and you'll notice that we'll go from this line, we go from that line, and we look up or we look down depending on which way we're looking. Okay? We never look from this way to this way. That's not what we do. We always look from that point there. So for that axis there, sorry. Any questions? No? Okay. Did you guys learn about exact values last year, sorry? Yeah? So you guys pretty familiar? How were you taught to just memorize the table? Can you put your hands up if you were taught to, if you remember about exact values? I'm talking about this stuff here. Put your hand up if you're not forced, sorry. No one put a gun to your head. If you memorized it by a table. You put in your resource book. Sorry, you learned it via table. Yeah? Does anyone know where this table comes from? No? Okay. Yeah, it's to do with the sine graphs, but the idea is these angles should give us very specific results. And the reason is because these special angles, specific angles, derive from special triangles. If I was to draw a triangle, and let's say, as a most basic unit, I say that the length is 1, and that's 1 there, assuming this is a right angle triangle. What are the other angles inside this triangle? James? Good, 45 degrees. Or in other words, pi on 4. Yeah, same thing. So, based off that information, what is the length of a hypotenuse? It's Pythagoras. Root 2, thank you very much. Root 2 is just Pythag. Now, with this, I know all the special angles with the 45 degrees. So, what's sine? Well, let's pick 45 degrees. Sine of 45 degrees, opposite over adjacent, over hypotenuse, sorry. So opposite, 1 over hypotenuse root 2, done. Right? So you don't have to memorize it, but this is how we go about it. So, sine would be 1 over root 2. What about cosine? So, if I'm looking at this angle there, the adjacent would be 1, and the hypotenuse is root 2, and we get the same answer. Yes?
Just wondering, in a test, will you ever be asked to explain why they're those values?
No, you will not be explained. Not be asked to explain, sorry. But this is... So go for it.
So all I need to know is just the value and that's it?
Theoretically, yes. But have you ever wondered why?
Not really.
Jay, that hurt my feelings. Okay, so this is how we find it, and we can find those values from there. If we're going to continue, we could go, well, let's say, what if I've been given a triangle? And let's say, instead of 1, let's say the side, and this is an equilateral triangle, by the way, the sides are 2. Okay? I'm going to cut it in half, so it looks like this. I'm going to redraw it over here, just because we'll try and get it a bit neater. So that's 2, and it's a right angle there. What's the bottom length? 1. What about this? Oops, that's not what I meant to. What about this side length here? So we're going Pythag, right? So 2 squared equals to 1 squared plus, let's just call it b. So 4 equals to 1 plus b squared. B equals to, I'm skipping a couple of steps, root 3, thank you very much. So this is root 3. Now, how many angles, or how many degrees, sorry, in each of these angles over here? 60 degrees, thank you. So we've got a 60-degree angle there, and that implies it's going to be 30 degrees, good. Once again, I've been given a triangle that's got those accurate measurements, and I can go ahead and find, well, how do we find the different angles? So let's go with sine 60. So I pick this angle there. I'm saying the opposite. So the opposite would be root 3. So sine 60, root 3 over, and the hypotenuse, which is 2. Okay? Let's go ahead and do sine 30. So sine 30, so I'm saying that I'm looking at this angle over here. The opposite would be 1. And then the hypotenuse will be 2, so 1 over 2. Okay? Now, I'm not going to get you guys to fill this in today because it's not actually what's being covered in exercise 14B. But as we continue, you're going to have this, at least this table in your resource book, and you refer back to it, understand where it comes from. You don't have to explain it, but you need to know where it comes from in terms of applying SOHCAHTOA in those exact values. Okay? With exercise 14B, a lot of it is just, not all of it, it is just looking at the idea of the symmetrical properties of the unit circle. So what we were talking about earlier in terms of the angles being the same. Okay, so please go through exercise 14B by hand, unless it specifically says use a calculator. Otherwise, if you need any help, let me know.